Cathepsin K protects against chronic alcohol-induced cardiac dysfunction.
All right, so first of all, thank you all for being here in the first place, and good morning to everybody. My name is James Austin Davilla, and obviously, over the past 6 weeks, I've been researching the topic of deletion of cathepsin K and how that protects against chronic alcohol consumption and cardiac dysfunction. So, starting off the background, right? Cardiac dysfunction is the decrease in efficiency of the heart, and that leads into chronic alcohol intake. Okay, so chronic alcohol intake is the third leading cause for cardiac dysfunction, the decrease in efficiency of the heart. So it's one of the 3 leading causes, and as such, it's a major deal, because as the CDC quoted, there's essentially 610,000 people per year that die due to cardiac dysfunction. Now, that's a staggering number of 1 in 4 deaths in the United States. So if we can fund any research to help prevent this sort of disease, we can essentially minimize that and save hundreds of thousands of lives each year. So, as my title would suggest, we are deleting cathepsin K. But many of you are probably asking yourselves, what is cathepsin K? Cathepsin K is an enzyme found naturally in the body. Now, its job is to delete certain proteins that are unneeded within the body as well. It can be found in the bones, as my mentor once stated, and it can essentially keep your bones at a certain mass. Now, there is a family of cathepsins. Another commonly seen cathepsin is cathepsin L. That is irrelevant to this study. So, previous studies have linked an increase in cathepsin K to hepatic disease as well as cardiac dysfunction. The overall goal of our study was to determine whether deleting cathepsin K actually prevented alcohol-induced cardiac dysfunction. And throughout our study, our hypothesis was the deletion of cathepsin K will protect against cardiac dysfunction. Very positive way to go about things. So there is, or was, a long sort of list of materials and methods, but I'm going to hit the high points of all of this because really who wants to hear about cell culture and all that. So the first thing that we did was alcohol feeding, and that was kind of the backbone of everything. So for a period of 13 weeks, we fed our rats, or mice, 5% alcohol solution. Now, this would mimic what a chronic drinker would sort of go about in terms of the damage to the liver and the heart. The next sort of material or method that we used was echocardiography. Now, many of you ladies have had children, as can be seen, but you can think of this sort of like ultrasound. So instead of looking at a little baby that's growing inside of you, we are looking at your heart and sort of the geometry, the wall thickness, and its sort of function throughout the body. We did this in order to see what the differences were between our standard control mice, which were the wild type, and the cathepsin K knockout with ethanol. So later on, we will see what the differences between the two were. The 2 other main sort of methods that we used in our study was protein assays. Okay. For the longest time, I thought this was assay with an E, but it is with an A, just like everybody here now. So what we're doing is essentially dyeing the samples that we had in order to find the concentration of the proteins in it. So that leads into our next sort of deal and the main sort of way for finding data in this specific study. So that would be Western blotting. In Western blotting, we took the heart cells that we had from our protein assay, okay, and we essentially threw those into a gel, an electrophoresis gel, and separated them from the other proteins in the sample, since they were originally pieces of heart tissue. Now, that led into this, which is our Western blot results. So as you can see from here, this is our wild type, and this is our wild type with ethanol. Now, the amount of cathepsin K that was found in the normal wild type was substantially less than what was found in the wild type with ethanol. There was essentially a 0.5 increase within this range, and that's extremely bad, because what that leads to is bloating in the heart and an overall decrease in efficiency, as I've kept mentioning. Now, chronic alcohol treatment was, the main study of this, but its effects were very interesting. So, in terms of heart weight, there was a substantial increase in heart weight with just the normal rats with the ethanol. This can mimic humans to a T. We all gain weight when we drink, right? I think most of the older people here would know that, if they had any experience. So, what we've done with the cathepsin K knockout and ethanol is essentially return that to a normal state. So our heart rate is back to normal essentially, which is fantastic. That leads to an overall more efficient heart, and that keeps your body way healthier than it would otherwise. You won't die that way. That's what we want. So in terms of body weight, we didn't really notice a change because, again, you're still drinking alcohol, you're still getting fat. That's what happens. But in terms of the ratio of the heart weight to the actual body weight, we returned it back to a healthy state as well, which is what we want, because if your heart is too big for your body, it's not going to be working properly, it's not going to be efficient. That's not what we want. That's what leads to heart attacks and other cardiovascular diseases. Now, our final results here, the actual heart function and whatnot, however that functioned, was our wall thickness right here. This is decreased because, again, it's alcohol. It does the same thing that it would to your liver. So it's essentially going to degrade all the cells in your heart due to the metabolites of the alcohol, not necessarily alcohol itself. Now, these are both the separate sort of stages of the heart with contracting and expanding. But in this one here, which is the expanding, I believe, there wasn't much of a change due to the fact that, well, your heart's going to stay the same size. It's not really going to do anything. But in terms of contracting, since we took out the cathepsin K, it was able to contract more efficiently. Once it was able to do that, the body was able to return to normal, and that kind of leveled off. Now, those are kind of side notes. The main thing that we want to focus on is the fractional shortening. This is the full sort of palpitation of the heart. Now, with the wild type, which is our main control here, this is what our model should be. It's going to be around 50%, okay? Now, with the ethanol-induced sort of mice, we definitely saw a decrease in that, and that's not what we want. That means that less blood's being pumped through your body, nothing's going to function right. Now, with the cathepsin K, same sort of deal. Not really a big change, same sort of mice. But with cathepsin K and alcohol, it was actually the exact same thing, and that's exactly what we want. We want our heart to stay as healthy as possible and be as efficient as possible. So, in reality, our project worked perfectly. This is exactly what we want. Now, to conclude, cathepsin K knockout improves cardiac function, as we've seen. It's also got a massive improvement in fractional shortening. So, a healthier heart, healthier life. Cathepsin K also allows for normalization of LVESD, so that's the contraction of the heart, after the ethanol treatment, which is, again, a positive thing. We don't want your heart to not be pumping blood. So, overall, this supports our evidence, or this evidence supports our research quite strongly. And that also means that if we can put this into a sort of drug in order to hopefully treat that into humans, we can essentially fix cardiac dysfunction in terms of the alcohol sort of setting, which would again save hundreds of thousands of lives each year. So in terms of acknowledgements, I'd like to thank SRAP and all of its mentors, the University of Wyoming EPSCoR, the National Science Foundation, Miss Lisa Beta for being awesome, as well as all the SRAP staff. They were fantastic. Miss Ray, as well as Dr. Sri Nair for being fantastic mentors. And Tucker, my boy. Tucker has always been there to listen to all my stuff, as well as Coach. Coach is obviously, from the name, my life coach in terms of all of my stuff. So thank you guys for all your time and all of your patience with my presentation. So does anybody have any questions throughout my sort of presentation? Did I do a fairly good job?
Very well done.
Thank you. Thanks, Sean. All right, so thank you all again, because that was pretty stressful. Thank you.